as opposed to trying to remember all the steps once and then move to a page and they forget some step somewhere. Repeat the step over and over again. Now, assuming you've done this on both sides of the paper all the way to the very end, the next thing to do is to come over to the standard algorithm and use the same colors to see how those multiplication steps are inside of the problem. So here we got 1 times 6, and we're going to put the 6 down. It looks the same at this point. Next one, 1 times 9. Next one is 2 times 4 is 8, and 6 times 3 is 18. Here's our first difference. We know with the standard algorithm we're going to carry the 1 instead of writing it down below, so we do the orange up there. I go to my next pen color, which is blue, the pencil color. Now this is 1 times 5 according to the standard algorithm, and that's 56. And of course what we're noticing here is that's 56. And those are just blended together. Students are often seeing then how this is smashed to become this algorithm. When I get over to here, I've got 1 times 6 is 6, and 69 and 69 are both those answers. Here I've got 2 times 5 is 10, and I write that down, and I see 108, and I see 108. Here is 6 times 3 is 18. I add on the 1, make it 19, and that's 198, and that is 198. My next step is just to take my pencil and to put in the big old heavy 0 right there. That heavy 0, now students start to be able to say where it comes from. It's coming from these place values that are retained when we do the expanded algorithm or an expanded form of it. We can see where the powers of 10 are in there, and that has to be preserved to keep the powers of 10, the values in this. So my next one's red. 2 times 6 is 12, and I carry that 1. 3 times 9 is 27, and I carry the 2. 3 times 4 is 12, I carry the 1. 4 times 6 is 24, and I cross this out and carry the 2 above it. And I go to my green color. 2 times 5 is 10 plus 1 is 11. 3 times 6 is 18 plus 2 is 20. 3 times 5 is 15 plus 1 is 16. 4 times 6 is 24 plus 2 is 26, and I add them up. Of course, I'm just showing you the front of the paper, not the back again, because it would be really valuable if students did this on both sides all the way, pursuing one color per step for the entire page. 6, 7, 1, 1, it's the same answer as that. This is 9, 3, the 1 gets carried through, 2, that's the same answer as that. 8, 2, 7, 1, that's the same answer as that. And 8, 13, 1, 8, and 2 is the same answer as that. And we've shown then how these two things are related. So again, this is a great way. It's kind of a search and destroy type method of rehearsing a step throughout an algorithm until that step is learned. And it also teaches students how these two algorithms are related, though they show place value differently.